Okay, so I'll change the graphics to plan view. Now, when you change the graphics to plan view, what you have the grid which is there is 50 meters by 50 meters. Okay? 50 meters by 50 meters. 50 meters by 50 meters. Okay? So now, we'll go to this function. Okay? Then we go to that function, then we go to the draw continuously, right? So I'm going to do a different design today. A bit different. Okay? So, I'll start with this point. I'll start with this point. Then I'll draw a line up to there. And I'll end here. Then to release the function, you just escape. Okay? To release the function, just escape. So now what is remaining is I need to construct the drifts, right? This. So for that, we need to use the two draw singles. So I'll draw singles at each 100 meters, okay, of 50 meters wrong. Okay, or 50 meters wrong. Okay? The single line has been constructed. Now, after this, we need to change the excavation section to arch shape or oz shape. Not so. So now here, I'm going to select everything like this. Okay? You select the star button, then you select everything. Then the spanner, which is the settings. The settings. Then in the settings, we change to arched. Then, okay. Okay, so the cross section has been changed. The cross section has been changed. So the cross section has changed. Now we need to cross the drifts because they have crossed ends. Okay, so that the air will not be, when you are going to simulate, it will not recognize that those excavations are open, so the air will be going. Okay, to consider them as crossed ends. Now, when you are going to do this, you need to choose each excavation one by one. Okay? Must be chosen one by one. If you choose all of them together, you may have a problem. Okay, so it's better you choose one by one. So you select and you go to the settings, then cross. Okay. You go to the second, you do the same thing. You go to the third. You do the same process. And choose the last one. You cross it. Okay? So the drifts now, they are crossed. Okay? Now let's deal with the shafts. We are going to construct two shafts, or one shaft and one decline. Okay? One spiral decline. Okay? So now we are going to change this view to section X axis. Okay? Or you can press F function 2. Now I'm going to draw one or two shafts or a decline. Okay? So I'll draw two shafts, then later I'll draw a decline. So now I'm going to draw a decline of 100 meters approximately, or 200. I'll use a single and I'll draw the shaft here, and I'll draw another shaft here. Or ventilation lays. So I have the inlet and the outlet, right? For it to be similar to the actual design. Okay? Next one. So now we have the two shafts. Okay? Now when we have these two shafts, we need to change the cross section of the shafts to circular. Now you need to know that if you are using each cross section has got its own effect on the friction of the air passing through the tunnel or the underground construction that you have made. So the more kinks you have, the more air you lose due to friction. Now we are going to change these two to circular. Okay? No, these we can check, you can choose them. It's fine. Now, after we do that, okay? After we do that, it's very important to know that when you are going to move this to the excavation, the point at the bottom of the shaft is where you have to take the caisson. You hold the caisson from the point that you want to connect on the other excavation. Okay? So I need to fix the caisson here and there. Then I move the shaft or the ventilation lines to the orange, right? Or the grips. Whichever excavation where you want to fix your ventilation lines. So in this case, I'll select only one. In this case now, because they are on opposite sides, so we have to move one by one, right? So I'm going to select this one, then move. The green button is move. Then the second button is duplicate. Okay? This button is duplicate. Okay? So now we are going to move this. So you take the case at the bottom here because what I want to fix on the other excavation. Okay? Then I'll select also this one. Then I'll hold it from here. I fix. What happened? I think I moved another. I didn't deselect. Okay. I escape. Then I select it. around, then I move it. You know, when it is at the excavation, when you are connecting them, what happens is, when it reaches near to the excavation, it knows that I'm there. Then it's like it shows the other excavation to be near, so which means they are now connected. Okay? When you take them to each other, close to each other, when it becomes there yellow, then it is now connected. Now, if I take to isometric view, I can check, is it really circular? And are these of arched shape? Okay? Now, the second step we have to take is we have to say those excavation one, on one excavation we're going to say the fan, and the other one will be the outlet. So it should, what it does, you can't put on both sides the fans, because it will be like you are contradicting each other, meaning you are pushing the air together, meaning the gases they can't escape. So one should be the escape and one should be the inlet. So just the outlet and the inlet. Now, I'll go back to the plan view. In this case, I want to choose the ventilation laser or the shaft. So we have to change the view to x-axis. Now, we will select this one and change this function to surface. Okay? Apply. Now, also on the other side, we are going to do the reciprocal thing, or the same thing. Then we choose also it is surface. Okay? Or you can first choose one as the surface, then set the fan on it. Then you set the surface so that the gases starts escaping. Okay? Now, I'm going to set the fan here. Then I'll go to this view and I'll set a flow of 350. Okay? Then I'll say apply. Okay. So it is now going in the correct direction. If you see, it's compressing the air inside, right? Now, if we press function F5, then the simulation will start going on. Right? So this is the escape and this is the inlet. Okay? What's happening? They are not connected. Okay? So, Actually, you can change the direction of the flow. Okay? If I wanted this one, now I've set already. For me, in my case, I've set already the fan on this shaft, right? Now, if it is pumping in the opposite direction, it's not going this way, you can change the direction. So we go back to X, then if it was here, I select, then this function, you know, there is like a circle, like the way it is in Slab, there is clockwise and clockwise symbol. This symbol, if you take your cursor here, it tells you to change the direction, so you can change the direction of the flow. Okay? You can change the direction of the flow. Actually, there are a lot of functions here. These functions here. So, heat sensibility. So, you can add all this information if you have calculated or the mine have given you these parameters. You can insert them in the program for you to check how it's behaving. Also, contaminant concentration. If there are some contaminant, dust concentration, how many milligrams per cubic meter are there? You have to add that information. Okay? You add that information, you insert, you give it those parameters, so that when it is simulating, it is giving you the actual information to the actual situation. Okay? Then if you go this way, you have like CO2, right? Oxygen, you have carbon dioxide. So if you have those percentages or they are different in your case, then you can insert them. Yeah? Question? What I did was, it's the same process. This same dialog is the dialog we are using to set the fan, change the cross section. It's the same dialog, but there are these other functions. Okay, all these other functions, so they are all used. It's the same function. Okay. Now, I want the drifts, they are not connected to the haulage. So we need now to connect them so that even them, now there are some air going into those excavations. So what we do is we have to change the cross section, the graphic interface to plan view. Okay, then we are going to select the excavation itself. Then we are going to add a fan, and in that fan I'm going to say I want 6 cubic meter per second of air flowing into it. Then I'll move to the second one. That's 6. Okay. And I move to the last one. Then I add also 6. Okay. So meaning you have set a fan which will be pumping 6. Now, if you can see, there is no air flowing into those. Not so. I've set a fan, but there is no air flowing into it. So I need the ducts. Okay? The construction duct. So we need to set up some ducts. Now, how do we set up the ducts here? So, the ducts, we set them this way. So I want a duct to be from here up to the other far end. I want to construct a duct from here up to here. Okay? So now the construction duct is this symbol where I've taken the cursor. No, it's not a duct, that is a node. So first of all, we need to construct a node. Okay? On that node, that's where I'm going to join the construction duct. So now, let's add a node. We just need one node, and we are going to place it here. Okay? So we have a node. Now, I'm going to select all these sections where the construction duct is going to pass. Okay? From that, this is a section, because wherever there is a drift and the orange, there is a connection. So it will consider each section as different. So you have to select them all. So I'll select them one by one. And that one, right? Now, after that, after we select, then we go to the tools. Then we construct a duct. The duct will be of the diameter of 1.2 meter. That's quite good. Then I'll say construct. So the duct has been constructed. Now, if we take this in an isometric view, we can see that there is a duct, right? There is a duct. Ducts are constructed in order to facilitate the smooth flow of air, because the circulation should work quickly and the air that you are compressing in may be reduced. The speed may reduce, and the amount you are getting at the far end is less to what you expect. So now, in this duct, we need to set a fan, and we are going to say that fan will be transporting about 50 or 60 cubic meter of air per second. Okay? So we are going to select the duct, which is this one. Then after we select the duct, we are going to set a fan. Flow, I want a flow of 60 meter cube per second. Warning. So you see where this has happened, because I'll take it to the isometric view and check. Do you think these fans, they are in the duct or they are somewhere else? They seem they have facilitated some new fans in the excavation, right? That's what it is showing here. Because you can see some improvement of the air flow in the orange, right? There is an improvement. We are having less, but it has improved. So meaning I didn't fix that on the duct. So let me change it to let me select. Okay. Now after I select, Now, this flow is in the duct. Okay? I have set in the duct. But as you can see, it is telling you that there is a conflicting of flow because we have the fans, and those fans are created inside the tunnel, or the orange is conflicting with other fans, right? So let's roll back. Roll back. Then I'll select well the duct, and I'll set the flow over 60. Okay. So I have the flow now. In the duct. Now, then I choose the correct one. Okay, that's it. I'll bring it back to the plane view. I'll select the duct and I'll set symmetric. Okay, so what it has done, it has fixed the fan here, and it has fixed the fan at the end of the duct. I want them. Okay, that's fine. Now, but there is no air flowing in the duct. I want the air to be flowing in the duct. So there is still a problem. If I do F5, okay, because there are 7 airways, they are not connected, so it's saying fix before over restricted airways. Okay, now let's fix the drifts. We connect them, we make the ducts and connect them to the orange. So now for us to do that, we need to change to plane view. Now on each of these we are going to add a node. Okay, so I'm going to add a node here. There and there. Now after that, I'm going to construct a duct. Then in that case now we need to select, and after we select, you construct the duct. Okay. Then we escape, select the second one, and do the same procedure. We build, escape, select the third one, construct the duct, build, and now escape and select the last one and construct the duct, build. Now when we take it in the isometric view, it will be like this, right? Now we can see that there is some air going to the excavation, right? Of 6 because we set it to be 6, right? But now that duct should be connected to the main duct in the oil. It's simple, right? Very simple. Huh? Yeah? What? No. It's not much I do with the for a video. Okay. Now, we need to connect these ducts to the main duct in the orange section. So, what we will do is we are going to select this duct, right? Then, actually, you don't need to select, you can select. Let's set a fan here on the ducts, the one we have created, these ducts. So we select it and we set the fan. We give it maybe 25, 50. Okay. Then I move to this one. I set a fan. Set a fan. Give it the floor. Select the fan and give it a flow. Escape. Now we need to join it to the main excavation, to the main duct. So I'll select it. Then change the view. Maybe it's not supposed to move. Just have to. Okay. It's not, I just escaped. You know, it's a long time I use this software. So what we need is to make a connection, so we need to draw. We draw a connection from the other one to the other one. So let's connect one. I want to connect from here to this. You see? It gives a yellow line to guide you that I'm on the right position, not on the excavation, but on the duct. Okay? So you connect it. Then we go to the other one also, we do the same process. So, you know, the way it is moving, you see the arrow, right? That is on the excavation, it's not on the duct. So, I want it to be on the duct. There is a duct. Okay? So, I go to this one, I do the same thing, and I go to the last one. I do the same thing. No, I escape this. Okay. So, if we see very well, if we check very well, essa minha de outra funcionar. It's not a part. I'm coming.
Problem has been sorted out.
So it's not the battery, it is what then? Okay. So if you check very well, we have done all these steps, right? All the steps have been covered. Okay? Though the amount of air we are using is a bit different, but we have covered all the steps. Okay? Now, how can we duplicate this? So, most of the excavation in the underground, they look identical, right? When you, they are not identical, but they look more similar. But if you are similar in a practical way, we can duplicate the excavation that we have. So, in this case, I will select what I need to be duplicated. Okay? Then after we select, then we are going to choose this function and move, right? So you have two identical stuff. Okay? You have two identical stuff. Moment. That one is there. There is a green one and there is a blue one with two. Like when you are playing music, they are those.
Oh. That's nice, Got you that you said,
Maybe you closed it accidentally. It's a dynamic monitor. This one. Yeah, click on the dynamic monitor and see. Is it? So, now, how can we fix this to this excavation if we know the level? So now, I want to move this to the correct position. Okay, now what I'll do, I'll take it to a symmetric view so that I can press this one on the right position. Okay, so we want it to be connected here. Okay. Then in that case, function f. So now it's saying there are some conflicting, right? Some conflicting stuffs that need to be fixed. So it is saying conflict with fixed flow. Also, so what if I was going to remove the fan which is on the excavation, for example? I'll choose this excavation, then I'll go to settings, the flow, then okay. Let me see if I say f function file. So on that excavation, I've fixed the problem, right? So because we have put two fans, there is a fan in the duct and there is a fan in the excavation, so they are conflicting with the air. So the other one has less pressure, the other one has high pressure. So they are conflicting. They're dancing. Mimi me gusta que ellos se bailen. Okay. So let's try the function. Define. You know, you want the air to be going in the drifts at 6 cubic meters, and then you have air in the duct at 25. Is there an equality? No, so that's what it is. That's conflict. Which other way around? It can work, but what will happen is the air now will start going to the gap, right? So it can be going now back. So that will be going now. Okay, now, in this case, for example, what if we add a shaft somewhere, right? We have a decline in between here. I want to join a decline. So I'll set to plan view. And now I want to create a spiral decline. So now I'll say I want to draw a single from here to there, for example. Okay? What is concept? Huh? That's how the software has been made. It's not conceptual. They are trying to tell you this is what you have to do, not what you think is right. This is what I do. No, you follow procedures. Huh? Follow procedures. These are algorithms that they have developed. An algorithm is just the way you take things. How do you process? So you follow the procedures. Now, to create a decline, we have to go back to the same tools, then say construct a ramp. So get that ramp, and you click somewhere. So there, I want it to be at that position. That's where it will start from. Now, you have the radius, right? There is a radius, there is a straight line, there is a radius segment. Then what is the initial bearing? The bearing is 60. Now, gradient. You guys, the question is this. What is the optimum gradient of a ramp? Or a log or the optimum transportation of ore from the mine. What is the optimum gradient? Huh?
1 in 7.
1 in 7, say the percentage. No. This specific, not 14, 6, what? 15%. You change 1.1 to 7. What is 1 to 7? Huh? 30 degrees. You know what is 30 degrees? So if it is 30 degrees, 45 is 100%. So what is 40 degrees? Okay, this is not mine planning or surface mining, whatever sound problem. I've done mine planning. You should know. How can you be saying 6, 15, 7, what? The optimum is 8. It's 8 now because due to force, they go up to 4.5. That's why you are seeing 12.5. They're probably not saying 12.5 already. One of those two. You guys. Even 1 to 7. What is 1 to 7 in percentage? Because that is a ratio. Huh? So what do you mean? You go on the board there and draw. What is 1 to 7? What do you mean by 1 to 7? Yeah, go and try and draw a figure for 1 to 7 there. We are waiting for you, sir. This gradient is 12.5. Now, can the track, which is going to separate from that decline, access the ramp? Or it can't? So, dependent on the track also. some trucks they can, some they can't. And the road that they are going to carry, not. Okay. So now, that should have been done in Sabbath. So, now, if I am conversant with this, if it is 200 meters, that's the depth, I put 200. If this is the radius, then it's fine. Then I say, build. Okay? So we have the ramp, right? We have built the ramp. Now there also, there was, if you saw, there is a clockwise. So if you check clockwise, then it will be clockwise. Don't check anything, it's designed clockwise. Yep. Now, I want to join this ramp to that excavation, right? So I'll change the view so that I can see where I'll take it to isometric. Now you see how it has drawn, right? It is going the other way around. I want it to come the other way around. So what I'm going to do, I'm going to reverse one step. I'll take it in the plan view and I'll create another ramp. I'll choose this one clockwise and build. Okay? Now, after I do that, then I'll take it in the plan view, isometric view. To join this to there, but it will not allow me because it's going the other way around. Okay, I'll pull this and I'll bring it up just for demonstration purpose. I'll select the ramp and we are going to move the ramp, which has directed something else as well. Now this view is difficult for me to see. Okay, so now I'm going to bring this
Is there a way to move the ramp in coordinate system?
There is, yes. There is a coordinate system there. For example, if it was coming to this drift, if that was the excavation, then we can join it to that. Then let me press function F5 and see the same. You know why it's giving an error? Tell me what's the problem. It's blinking red there. Why is it giving red?
So, you've not selected it as an output.
Yeah, so the answer is this one has not been chosen as a surface. So we need to choose this as a surface. Or a surface or a closed end. But in this case, it's going to be a surface. Surface. Okay. Now it's flowing, right? It's flowing. Not so. It's flowing. Yeah? These are just like, if you have there is already an existing mine planning, right? Another software for planning. Now, if you wanted like, there is need to get another excavation, you can do them in Ventsim. But if you already have, you just need to report the power from other softwares, right? So, this part ends here. So there is no need again, repeat this class again, right? You have understood, not so you need to practice. It's the same one where we connecting the other sections. It's the same, you connect. If you have the coordinates, you can use the coordinate system. You create it following the coordinate system. Okay? Now, I'm going to save this. Okay. Now, like we said the other day, we import a file from Slab. Then, which excavation do you need from here? Okay, so we have a one. If it is O, I pick O. Then you convert to whatever. Okay. Import. Then it will be like that. Now, I think I did another one. I guess there was another. Let me do something with Slab. Over restricted. Meaning you have two conflicting, right? There is no conflict there. Should be saying some conflicts, right? No? Okay. So, it is importing from Slab. We can import files from DXF, datamine, micro station, text, datamine is there also, DM, which is datamine, is there, and multiple flux. So multiple flux maybe. These are other softwares that are related to the same flux models where you are flowing material. Okay? Now, so if we import, we just import it that way. Then we choose it and we import. So I have the file ready. Okay? And what should I do?
I'm trying to.
So you click the function. Function. So there is one system frame. There's some Okay. So if you are going to import, you import, then you work on the already design. Okay? So in that case, you have just to follow the same procedure that we are using. Then all is fine.